রাজেশ কুমার স্যার জয়েন করেছে?
না এখনো করেনি, উনি করে যাবেন, আমি ফোন করেছিলাম।
আচ্ছা,
আমাকে ভূমিকা ভূমিকা ভূমিকা
ফার্স্ট লেকচারে ওনার না?
হ্যাঁ হ্যাঁ
ঠিক আছে, উনি জয়েন করলে আমরা তাহলে স্টার্ট করতে পারি।
ওনার জয়নিং একটু হয়তো দেরিও হতে পারে। আমার মনে হয় জিনিসটা একটু স্টার্ট করি, ঠিক আছে?
Next, Nicola has joined. Nicola, how are you?
Hello, good morning. It's morning here in Croatia, so good afternoon to you. It's great. It's nice weather, so yeah, I'm fine.
Thank you so much for joining with us.
Thank you for inviting. I will be joining anytime if you have desire.
We are very much happy that you have accepted our invitation and you have joined. Okay, so Dr. Shah, we should start or we shall wait? Your microphone is off.
ভূমিকা
Yes, sir.
স্টার্ট করো।
Okay.
Dr. Nicola will start and then after that we'll invite the other speaker.
Okay, so can I start now or?
Just wait, sir. There is an introduction. After that, we will start the lecture.
Okay, thank you.
Bhumika, you please start.
Yes, sir. A very warm good afternoon to all the delegates and participants. First of all, I would like to extend my sincere greetings on behalf of South Asian Institute for Advanced Research and Development, and welcome you all to the second day of this international webinar series on geospatial technology and water resources. In recent decades, geospatial techniques have gained considerable interest among the earth and hydrological science communities for solving and understanding various complex problems and approaches towards the water resource development, and hence a topic becomes more important to discuss. We are pleased to have Mr. Rajesh Kumar, Director, ISM 2nd Central Water Commission, New Delhi, India. Dr. Nicola Francis, Assistant Professor, Faculty of Geotechnical Engineering, University of Zagreb, Varasadin, Croatia. Dr. Neelanchal Patel, Professor, Department of Remote Sensing, Birla Institute of Technology, Mirza, Ranchi, India, and Dr. Ratnakar Singh, Assistant Professor, Department of Civil Engineering, National Institute of Technology, Rourkela, India, as our guest of honor today. We are also obliged to have Dr. Satyavati Vishwas, Associate Professor, Mirandi Datta, Mahavidyapith, West Bengal State University, India, and Dr. Mayank Suman, the Assistant Professor from Department of Civil and Infrastructure Engineering, IIT Jodhpur, India, as our distinguished speakers for today. With this, I'll conclude myself, and at last but not the least, I would like to thank all the participants and partakers for joining this webinar. Now, I would like to invite Dr. Sahu, Faculty of IITST, as well as the convener of this event, to welcome our guests. Over to you, sir.
Okay. Thanks, Bhumika. Thank you, everybody, for joining this webinar on international webinar on geospatial techniques and water resource management. It's a very important for future water resource planning and management purpose, because now we are facing water crisis program over the world. That's why we have arranged this kind of webinar for decision making purpose. So I would like to welcome to our guest of honor, Mr. Rajesh Kumar, Director, ISM 2 Central Water Commission, New Delhi, India. And I would like to welcome to our honorable guest, Dr. Nicola Francis, Assistant Professor, Faculty of Geotechnical Engineering, University of Zagreb, Croatia, and another honorable guest, Dr. Neelanchal Patel, Professor, Department of Remote Sensing, Birla Institute of Technology, India, and Dr. Ratnakar Singh, Assistant Professor, Department of Civil Engineering, National Institute of Technology, Rourkela, India, and another guest, Dr. Satyavati Vishwas, Associate Professor, Minaliti Datta Mahavidyalaya, West Bengal State University, and our honorable guest, Dr. Mayank Suman, Assistant Professor, Department of Civil and Infrastructure Engineering, IIT Jodhpur, India. So I think it's a very good webinar for various water resource persons like various scientists, various engineers, various research scholars, various university students, undergraduate, postgraduate students. So because this kind of program, water crisis program, remote sensing and GIS technique can be solved this kind of upcoming issue, because now we are facing the water crisis problem, water climate resilience problem. That's why we have arranged this kind of webinar for decision making and policy purpose. Thank you all. Thank you everybody. Over to you, Bhumika.
Thank you, sir. Thank you for your words and welcoming our guests. And now I would like to invite Chairman Sir Dr. Biswajit Roy Chaudhary to address our guests, as well as I would like to thank him for giving us this opportunity to conduct this webinar in this institution. Over to you, sir.
Thank you, Bhumika. Thank you, Dr. Shahu, the convener of this 2 days international webinar, as well as our honorable guest from Dr. Rajesh Kumar, Dr. Nicola, and all the resource persons, those who have joined from the different corners of our country for delivering their resourceful lecture on this particular issue. So the concept which we have designed for this particular webinar, that is the geospatial technology and the sustainable water resource management. As you know that the government of India has a vision regarding the water resource, and nowadays continuously this natural resource is becoming a highly alerting situations as well. So we should protect these resources, and we have to think in a modern way how technology can be can save this natural resource for, and also how this how through the application of this technology, geospatial technology, we can protect them and we can manage, we can proper policy at making advocacy, we can prepare as that these resources can be saved. And in this regard, from the last yesterday, we had got a resource person, 6 resource person from the different parts of the corner, different resource person, and they are delivering their lecture on the various issues related to the focal theme of this event. And today, though it's a last day, but today we are also be enriched how we are through the lectures by the resource persons, those who have joined. So with this, I expect the highly successful conference of this on the focal theme, and we are also looking forward to organize this international conference in a physical mode also in coming days as well. So I expect that there you may also support us in this regard, and your guidance and your support, your visionary plan will also help us for the development of these resources, as we are mostly working on the geospatial technology as well as the water resource sectors. So with this, once again, I thank to all of you, particularly the resource persons as well as our participants, and not but least, last but not least, our convener, our faculty members, our team members for organizing that such a wonderful event. Thank you. Over to you, Bhumika.
Thank you, sir. Thank you for your words and for addressing our guests. Uh, Now, I would like to invite Dr. Nicola Grantis, the Assistant Professor and the Faculty of Geotechnical Engineering from the University of Zagreb, participant for Croatia, to speak and advance our understanding of the use of geospatial and remote sensing techniques in Croatia. Over to you, sir.
Okay, hello. So just let me share my screen and start the presentation. First of all, can you see the screen? Please just confirm. Okay.
Yes, sir.
Yeah,
Yes,
now
sir.
Okay, great. Okay, so first of all, I would like to thank you for a nice introduction and for organizing such conference. As our chairman today said, that this is something that is most important to use in the future. And today I would like to show you in a couple of 10 to 15 minutes how we use geospatial and remote sensing techniques in Croatia. But first of all, while we are mentioning some future of geospatial and remote sensing techniques, we should be focusing also on I will show you a brief history of geospatial information systems, how we managed to do something before computers. As who you are dealing with remote sensing and geospatial techniques today, you have a lot of data and you need a lot of computational power. Everyone who is working with these techniques can be familiar with this issue. So the presentation will be separated in several chapters. First of all, I will briefly just introduce, then I will show you a brief history of GIS, how we did it before computers, remote sensing and GIS examples from Croatia, what we did, what the government did in order to allow us to have better framework in order to work more detail with remote sensing techniques. I will speak just briefly about drones in Croatia and legal part, because remote sensing as well, we are dealing with satellite missions and some other aerial photogrammetry that is organized by the state, but also a lot of private companies are using drones and they need to be regulated as in Croatia, as also in the whole world. So as we heard in introduction before from our chairman and honorable guest, that the field of geographic information science or systems has really advanced over the few past decades. And it evolved from theoretical concept of digital creating map into array of methods and software with wide-ranging applications. So geospatial technology now offers much more than a system for capturing and organizing positional data. You know, before you had only one GPS or something and you put, okay, now I have coordinates. Today, this is much, much more than organizing positional data. Spatial problem-solving approaches can be adapted to meet needs like planning real estate projects, addressing public health crisis, or protecting national security. This national security has become an issue in the last couple of decades, as we know, and are witnessing wars all over the globe every day and some issues. So this national security and of course public health is something to consider in our researchers. And increasingly robust tools for mapping and visualization continue to emerge. Businesses, governments, and other nonprofits discover additional opportunities to harness insight for improved strategy and efficiency. And now I will break down some of the key phases in the history of development of GIS, just to get a small idea how far this technology that we are dealing with today, and also on this conference, how far we have come with this technology. First GIS mention or something like that was in 1854, when cholera struck the Soho district of London in Great Britain. And at the time, no one really knew how this infection was spreading, but they had commonly held the miasma theory, which suggested that this disease traveled through the air, something like COVID today. And then the physician named John Snow was skeptical of this idea. So he selected one map and he charted the outbreak locations alongside roads, water lines, and property boundaries. And he eventually realized that many of the cases stemmed from a single public water pump on the Broad Street. So basically, when he continued his research, he discovered that the water company was delivering polluted water from the Thames to the homes within the city, and then therefore spreading the infection. We are commonly using this map that you see on the picture here as the first application of GIS. Later, in 1960s, and with development of the computers, we concluded that maps could be used to solve complex problems, but such projects were difficult to undertake with pen and paper. It's difficult today with modern technology. You can imagine how difficult it was before. So by 1960s, computers began to change everything, making it possible to record and analyze geographical data on unprecedented scale. And the first one to explore the possibilities of GIS was the country of Canada, and later in 1965, the US Census Bureau also took an interest in GIS, experimenting with system to plot block by block demographic data. And then the agency used a GIS-based file format known as GBF, DIME, to digitalize information on roads, urban areas, and boundaries. The Census Bureau continued to use the DIME format until it was replaced by topologically integrated geographical encoding and referencing, or also called as TIGER, in 1990. I believe that all of you heard about the TIGER. What are we dealing with GIS today? And over the years, spatial databases and software has been adopted by all types of organizations, governments, local communities, private sector, etc. We have smartphones, tablets, drones, satellites, and Internet of Things sensors, and which all serve to expand the user base for geospatial systems while also collecting even more data. We collect, and we have more and more and more data. And basically, thanks to the open source community, the great deal of information is available for free, whether is it used to provide drivers with traffic updates, such similar like on Google Maps or on any other navigation tools, or share NASA's detailed perspective on other planets. With application and tools becoming more user-friendly, powerful tools are more available. Professionals in any industry can build and collaborate on major GIS projects. Many of the world's best-known businesses now employ software powered by geographic data to strategize new locations or improve logistics. So on that way, they can save money and have more profit. Urban planners use GIS to maintain regulatory compliance, evaluate environmental compliance, and make decisions about new developments. Today, GIS is relating information from different sources. GIS uses spatial temporal, space or time, location as the key index variable for all other information. Just as relation database containing text or numbers can relate many different tables using common key index variables, GIS can relate otherwise unrelated information by using location as the key index variable. And we are dealing with it, we are aware of it, but it's good to say it out loud again. Any variable that can be located spatially and increasingly also temporally can be referenced use GIS. Locations or extents in Earth space-time may be recorded as dates and times of occurrence and X, Y, and Z coordinates representing longitude, latitude, and elevation respectively. These GIS coordinates may represent other qualified systems and temporal spatial reference. GIS today, what are the uncertainties of GIS? Because we need to be, as experts, we need to be really careful while using open source data. So basically, GIS accuracy depends upon open source or source data and how it is encoded to be data referenced. Land surveyors have been able to provide a high level of positional accuracy utilizing the GPS or GNSS derived positions. High resolution digital terrain and aerial imaging, powerful computers, and web technology are changing the quality, utility, and expectations of GIS to serve society on a grand scale. But nevertheless, there are other sources of data that can affect overall GIS accuracy, like paper maps, though this may be limited use in achieving the desired accuracy. How are we capturing data for GIS today? We are separating in several main topics. First is classic geodetical field survey with GNSS, handheld GNSS or classic geodetic field survey, remote sensing techniques like cameras, digital scanners, and LiDAR or unmanned aerial vehicles, and satellite remote sensing. We have many global missions, many local missions, and many of these satellite mission data is free for use, like Copernicus data or from European Space Agency, or NASA data like Landsat. So it's free for use for any purposes. And some of the satellite remote sensing missions are payable because they have really high resolution. GIS today we are defining with spatial analysis, and we can use it for any of these here mentioned analysis, such as terrain analysis, proximity analysis, data analysis, topological modeling, geometric networks, cartographic modeling, map overlay, geostatistics, multi-criteria decision analysis, or GIS and data mining. Here we see one topographic and terrain map, and which is basically like this. We know what lines show what, but if we need to calculate the fastest route from point A to point B, then the GIS system is really useful and really powerful here. Remote sensing is the process, just first a quick definition, is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, typically from satellite or aircraft. Special cameras collect remotely sensed images, which help some researchers sense things about Earth. Some examples are like cameras on satellites and airplanes take images of large areas of the Earth's surface, allowing us to see much more than we could see while we're standing on the ground. Sonar systems on ships can be used to create images of the ocean floor without needing to travel to the bottom of the ocean. Cameras on satellites can be used to make images of temperature changes in the oceans. Some specific uses of remotely sensed images of Earth include large forest fires can be mapped from space, allowing the rangers to see a much larger area than from ground. Tracking clouds to help predict the weather or watching erupt volcanoes and help watching for dust storms. Tracking the growth of a city and changes in farmland or forests over several years or decades. And we have saw a lot of scientific papers on these topics because this is something that really affects our living space while we cut down the trees and expand the cities in order to have more apartments, more houses, more homes, etc. Or discovery and mapping of the rock topography on the ocean floor. How the examples from Croatia. And so I used some data from November in 2021. Remote sensing and GIS provided over 700,000 results on Google Scholar. Remote sensing and GIS in India, if you Google it, it will be around 150,000 results and around 10,000 results in Croatia, because this is similar. India is a large country with a lot of scientists, a lot of professionals that are dealing with remote sensing and GIS, and it is expected, while in Croatia has around 4 million people in total, so this is something that is expected. So I will show now a couple of examples from remote sensing, how remote sensing and GIS combined provided us with some services that we can use for free in order to gain additional special data or some information. So what you see here, this is one web address that is called the GeoPortal, and GeoPortal shows us different we can turn on and turn off different layers that we want to show and then print out. Like we can have cadastral parcels, we can select who is the owner of this parcel, we can see roads, we can see topography, we can see different base layers. Like you see here now, this is one digital orthophoto map that is base layer behind all these up layers, and we can select here from different years these aerial photographies, or from different types of maps, so we can have a lot of information. And this is fully funded by the government and European Union, so in order to enable free use of spatial data. Next is one similar to this slide that I showed before, but this is strictly used for cadastral parcels. So Croatia has cadastre that is where are shown data about different area sizes, etc. So you can see here, I don't know if you see my, you can see here that we see this says the area of catastrophe parcel that we see here catastrophe parcel that is selected. This parcel has its number, it has where it is located, and here we can click and see who is the owner of this parcel or owners of this parcel, and how, if there is any legal constraint in order to buy or sell this parcel. Also, it is connected to the Google Street View. So basically, when you locate your parcel, you can also click Street View, and it will show you where is this located in space. So basically, now I said a couple of examples. I will say briefly about unmanned aerial vehicles because I see that my time is running out. What is an UAV? It's commonly known as a drone. It's an aircraft without any human pilot, crew, or passengers on board. UAVs are a component of an unmanned aircraft systems, which includes adding a ground-based controller and a system of communications with the UAV. So basically, first, unmanned aerial vehicle. This is maybe information that will shock you. It was tried in July in 1849 during Austrian-Venice War because Austrians tried to bomb Venice with the balloons on which they mounted on-timer bombs, but they overcalculated the wind speed, so this was not successful. But the first example of unmanned aerial vehicle or the vehicle without crew was in 1849. What are we using digital elevation drones for today in Croatia? This is some examples that I did for some professional project. This on the right, we had one road that needed reconstruction, and because there was a landslide and asphalt damaged, and for civil engineering, in order to prepare a project, they need a digital elevation model, and I made it with a drone. I mapped all these houses. These are two separate images here separation. This is not connected. So I mapped all of these houses, trees, etc. with the use of the drone, which really enabled me to be faster and more efficient on the field. Next, we had one river. Yesterday, my colleague Bojan Đurin was dealing with this river, Plitvica, which needed to have flood control because during the winter it has a lot of water and it floods villages around this river. So also for project phase, it needed to be mapped and to be put in GIS, so the civil engineer could provide calculations and project in order to have better understanding of this river. And I think this here on the left is one of amazing photo. What are the law requirements for drones? Law requirements for drones started as expected in the United States of America in 2012. Today, they had last year. In USA they elected this remote ID rule book in order to control even more users of drones. So basically, you cannot lift drone without the government knowing that you have the drone, that you are operating, and where are you located. They are putting it on the card of the safety. In Singapore, in 2015, they had first law. And in 2025, all operators needs to have driver's license. And if you don't have it, you get 20,000 euro fines. And if you repeat it, then you get jail time. In other countries, more similar, there are forbidden flights around specific objects such as airports, military objects, or nuclear plants. And it's similar in Croatia. We need to have a couple of licenses in order to fly the drone. We need to have licenses later to use the drone photographies, and all this is under the jurisdiction of Croatian Geodetic Administration. I'm sorry I went over with the time. So this I would like to thank you for attention, and if you have any questions, please feel free to ask me. And again, I would like to thank International Institute of Geospatial Science and Technology for inviting me to hold the lecture here on wonderful conference on geospatial technology and water resources. And I wish you all of you today a really fruitful conference, and to learn something new and to gain new collaborations, etc. Thank you really much.
I would like to invite all the attendees of this webinar to raise any questions if they have any.
Yeah, so I have a question that what is the scope of geospatial and the data analytics in geography, if I want to pursue it?
So we have yes, hello, thank you, Mr. Daniel, for question. In Croatia, we have different schools we have specialists on geodesy and geoinformatics. This is the school where I got my PhD. We have the School of Geography, also this is all based in Zagreb, University of Zagreb. This is the capital city of Croatia. So, but if you have maybe more specific questions about it, we can discuss it. You can contact me with a message or with a mail, so I will answer you in more detail, because this is really broad topic. We have a lot of different schools, so maybe based on your desires or some I don't know, preferences, so I can then maybe tell you, okay, maybe this is better for you, but this will suit you better than this one. So if you have, I would like to know more in detail of this question.
Okay, yeah, thank you. So can you please drop your mail in the chat box so that I can contact?
Yes, I'm writing it right now. And sir, if you send me through Gmail, I will then answer you with my private Gmail. So I will leave it also here.
Okay, yeah, sure. Thank you.
So you can contact me there.
Okay, sir. Thank you.
No problem.
Thank you, sir. As we don't have any questions for now, I'd like to really thank you for such an interesting session, and it has really enhanced our knowledge on the geospatial and remote sensing techniques. Now, I would like to invite Mr. Rajesh Kumar, Director of ISM, Central Water Commission, New Delhi, India, to address us and to enlighten us on the topic of water resource management in India. That is an overview. Over to you, sir.
I am very delighted to attend this WebEx meeting. Myself, Rajesh Kumar. I am Director, Central Water Commission in Joint Secretary grade, Ministry of Jal Shakti. I think that my topic would be general perspective on water resources. All of you know that India is a country with vast magnitude, north and south, east and west, and has lot of variation in water resources. From right around 10 mm to 15 mm in western part of Thar desert to more than 1000 mm in Meghalaya, maybe 3000, 4000 mm per year during the monsoon period. So, with such a spatial and temporal distribution of rain pattern in India, we have lot of variability of water distribution in India. So, if you excuse me, I will just take 1 minute for sending my mail to Mr. Sati Prasad, who is convener of this program. So, basically, India is blessed with, on an average, 3,880 BCM of rainfall per year. But all the water is not available for our needs. Some of it has to go mandatorily to sea, but amount of water which is available is only 1112 BCM, whereas the water assessment as per the available assessment of surface water and groundwater total assessment is 1992 BCM. This has been done by NRSC and Central Water Commission. So out of this, only available water is 1100 BCM around. And you know that after say 30 years, almost 30 years, when it will be 2050, then this much whole water will be needed for our consumption purposes. So basically our problem is that somewhere water is very high in quantity available to us, but somewhere that is very less water is available. So that spatial distribution is a great concern to our planners. So Central Water Commission, being the organization, apex organization in water resources, is planning to tackle this problem. And one of the obvious solution to this problem comes that we can make a link from high water available area to the scarce water available places. But there are so many difficulties in making this link. You might have learned in newspaper, if you are interested in water resources news, that Ken Betwa link has come with a long distance of negotiation between two states, MP and UP. These two states, being the states of same political party, were not able to reach to an understanding for long time. But recently, our Honorable Minister Jal Shakti has been able to make this great progress in this field, and an MOU was signed. Memorandum of Understanding was signed between UP and MP for utilizing the waters of Ken, which is less developed, in Betwa area, which is more developed. I think you are aware that Ken and Betwa are the tributaries of Yamuna River. And Yamuna River ultimately joins Ganga. So whatever water from Ken is possible to be brought to Betwa, then the area which is having low irrigation will be brought under good intensity of irrigation. So both UP and MP being a fertile area, so I think this will be a great leap forward for irrigation development as well as drinking water development in India. So interlinking of rivers is one of the major steps in achieving water balance in our country. But unfortunately, there are many hurdles coming in this way. One time, it was thought that Himalayan rivers will be garlanded and the water of Himalayan rivers will be taken to southern region. But there a lot of investment and so many other problems of interstate nature will be coming in between. So this problem is not so simple to be solved, but there are other methods which can suitably address this water scarcity problem, which is going to be faced by this country not very far away, but after just 28 years, when the water availability will be just equal to the demand. And then the population, you know, the population of India is 1/6 of world's population, but water availability is only 4%, just 4% of the total fresh water available in the world. So this fresh water of the out of this fresh water, only 50% can be utilized. That's what I told, that fresh water availability is, again I will repeat, that around 2000 BCM that is available, assessed, that has been assessed to be the water available. But out of that only 1112 or say 1100 roughly BCM is available, and that is the demand during 2050. So per capita demand at in 2011 was 1680 BCA, 1680 BCM was per capita demand, not per capita demand, the total demand. If I am mistaken, I'm sorry. So this per capita demand is hardly to be met in 2050. It will be a stressed country. It will be highly over water stressed country. So the situation is going to be not so uh, lucrative. So what are the methods? Government of India has thought one thing, I told you, interlinking of rivers. Second thing, improving the efficiency and reducing the wastages. So how to improve the efficiency? Agriculture is the field, irrigation is the field where 80%, 75 to 80% of the water is utilized. And their efficiency is hardly 40%. If you take this efficiency up to 60% or 70%, then the things will be, I think, much in a better position. That's what Government of India has launched a program called, I will tell you, the PMKSY, Prime Minister Kisi Sinchai Yojana. And that Prime Minister Kisi Sinchai Yojana is such a good scheme that government tried to focus on the schemes which are incomplete by just uh, making the scheme complete through funds or making other you can say things like monitoring of schemes. It is being done by Central Water Commission and even by the state government. And through proper monitoring and rehabilitating the old water bodies, focus is on triple R, that is renovation, rehabilitation, and restoration. So once the old water bodies are restored, a lot of irrigation facilities can be given to many of the places. And in that situation, the age-old pattern of flood irrigation and furrow irrigation, these irrigation has very much loss of water. So now a technique of micro irrigation and pipe network irrigation (PIN) has come, and we have been able to make guidelines in this regard. And India is also collaborating with Israel on micro irrigation. They are very much developed, and we are trying to improve our efficiency of irrigation as high as 80 to 90%. And as I told you that now the irrigation efficiency is not more than 40 to 45%. If you take it to 80 and 90%, particularly for the water states like Gujarat, Rajasthan, MP, and other parts like places, then you will be able to save a lot of water for other sectors utilization like drinking sector, industrial sector, etc. So the water demand is very less, but that is a prominent sector. Drinking water is considered to be the prime requirement of our all essential requirements. So basically, our 2012, this Ministry of Jal Shakti, this water guidelines, we have given its first importance. And you are finding that lot of pollution are coming to the source, and the source pollution are such a horrible thing that they destroy whole of the water body. If suppose some polluting industries directly leave their water into the sources like lakes and rivers, it is not being a natural type of water coming from industry. So that creates a lot of hassle for human health hazard. Lot of human health hazard is coming nowadays. Pesticides from agriculture and chemical fertilizers, then and antibiotics from the for pharmaceuticals industries, and so many other type of hazardous chemicals coming from the factories are polluting our ecosystem and particularly water. So one important thing is how to make a stringent measure towards the polluting industries, so that the direct access of these effluents of these industries is not going to the our freshwater bodies. But nowadays this is happening. You will be surprised that Yamuna River, whose water is being used in Delhi, is one of the most polluted river, and it's very unfortunate that in India that we are not having that much of even technology and even economically we are not so sound to have a filtration of these hazardous chemicals. Only 41 parameters are being now detected and even cleared, but many more parameters are coming, adding, and we are taking help of advanced countries, how to like Denmark, etc., for setting up of a smart labs where we can find out the pollutants of heavy metals, etc., and how to remove them. The government of India is trying to have such type of filtration plants, but so far none has come. Only our plants are filtering the biodegradable pollutants like human feces, etc. So we have to focus nowadays with upcoming of lot many industries and the waters going into the rivers, etc., to contain these pollutants going directly into the river, or if it has leaked into it, then we should have a proper micro filtration plants where we can filter these. So this is the need of the hour. Second, I will government of India has taken a lot of steps in water conservation, which is a must because most of the water which is coming in India is monsoon water, and the monsoon water comes only during 3-4 months of the year. So that water we have to impound. I will tell you that when the country was independent, 1947, only 15.6 BCM water was being able to be stored. Now we have made it around 257 BCM capacity for storing water. So this is a great leap forward. Storages have been made like Bhakra Nangal and many more storages in South India, Sri Salem Dam, Udupi Dam. So many storages have been made. So now we are trying, but problem is that due to rehabilitation and resettlement issues associated with the major projects are not easy to come up. And for minor projects which are coming up, we have one of the problem that either minor projects may come up, but problem is that minor projects may not be able to cater for the city need, which is growing excessively, population growing. So we have to go for major dams, but now situation is not that. Major dams, even sites are not available. If sites are even available, even then we are not able to make people realize about its importance, and there are often political interference, etc. So we are not able to make a major dam. But we are trying to have a water conservation, and in 2019, our Honorable Prime Minister launched Jal Shakti Abhiyan all over India. There are 256 water states, groundwater states, districts were delineated, and there technical officers were sent, and they monitored and give suggestion on how to make conserve water. So these methods are going on. Other than that, in agricultural sector, there is a need for participatory approach. If suppose government is doing something for the farmers and farmers are not taking interest and not thinking that it is their property, they will not be able to do justice to the available water. That means there will be inefficiency and wastage. So for that, Government of India has started with Command Area Development Program as well as Participatory Irrigation Management Program. This is Command Area Development Program is being associated by now all irrigation projects. That means on-farm development, making of water more and more utilization to be more effective. Then there are other methods. How to contain wastages? There are technologies coming up like IoT, where your instruments like water taps, etc., will be telling you that your wastage is much more than what it should have been. So you will be cautious. There are systems prevailing in other parts of the world where if you make wastages, you will be penalized. And if you save water, then you will be rewarded. So this type of blockchain technology is also coming up in water resources system. We are going for automation. Automation in the sense that our canal system, our distribution system, our dam system, gate system should be automated, and this will reduce the wastages as well as. One thing which is related to GIS technology is this water monitoring over the cropped area. Suppose you have sensors and they are sensed by the our satellites that this area is facing a lot of water. What type of area is this? What type of suitable cropping system would be prevailing for this year, or particularly with the time this time as per the time changes, then the cropping pattern could be devised based on the satellite imageries, etc. That what type of area, what suitable cropping system should be there. If water is available, farmers could be told to irrigate the water intensive crops like rice and this thing, sugar cane. Whereas where less water is available, they can be advised. And even the monitoring of fields through GIS system, the remote sensing, we can find out what part of the field is now needing water, how much water should be applied. All these type of things can be associated with GIS and remote sensing technology, as well as your high technology like sensors, etc., water sensors. So these are being taken up by government of India with help of Australia, etc. Being taken up, not so far. With help of Australia, we have a, IWRM, Integrated Water Resource Management System, and for efficiency increase, we have a pilot project. We are trying to going for a pilot project where we can do this sort of thing. But in Denmark or in Israel, etc., we have already these type of systems available all over the country. So they have also very reuse, recycle, good efficiency of reuse and recycle. So these all sorts of measure needs to be taken in India, because India is also very rich in water, but only water problem is this, that water available only during the 3-4 months. So those 3-4 months the water rivers are running full. At that time we need less water because our crops are getting rainfall water also. So the challenge is to store that water, then use that water effectively with all efficiency, so that our stored water is available, is able to irrigate the desired with desired intensity and desired utilization for the cropping system. One thing I will tell you, that apart from water management through irrigation, etc., one thing is important, that we change our habit to make water footprint more and more water footprint. So how can this be done? This can be done if we think that water is a commodity, and this commodity should be used in a very economical way. How it can be used? In Assam, suppose there is a lot of water available. In Bengal, some part there is a lot of water available. In Meghalaya, northeast water. That time when water available, we can grow rice and maize, rice and sugarcane, or even cotton, etc. That time we can store that water in form of rice, and we can send it to the portion of the world or portion of the states where there is a water scarcity and we cannot grow rice. Now what is happening? Punjab is growing rice, Rajasthan is growing rice. There is a lot of canal system over there, and they have plenty of water available. But what is happening, that when the water is not available, then they are using the groundwater. Groundwater position has such a such a disastrous effect in Punjab and Haryana. Places I have seen that tracts of tracts land has become barren because the groundwater contains a lot of salinity. And salinity, alkalinity, everything that comes on the ground after drying up, it makes your field barren. So they are not using judiciously the water. Water where there is available naturally, like in Assam, Bengal, etc., they should be their rice should be grown. But other area where groundwater is to be compromised, rice should not be grown. This type of cropping system, cropping pattern should be adopted. And the government being a democratic type of government, we are not able to emphasize on these things, but the state government have to think on this. And people have to realize. Main thing is the people. Once people realize that their land can become barren by using the groundwater irrigation, then they will realize, like in Punjab. And another thing that we have to go for cropping system suited to that area, then going for organic cropping. Organic cropping is such a system, such a nice system that not only the water is saved, not only we are saved from diseases, not only we save our land, we also become healthier. So how the organic cropping helps? This organic cropping inspires you toward more and more the cattle rearing. Cattle and farming, they are both linked together. Once we stop the cattle meat production or export, then that cows or the buffaloes or the bulls will be used, their dungs will be used for cultivation, and they will be much more productive than even biogas will be utilized, even CNG can be prepared. So these will be much more effective, and land water requirement will greatly reduce because the organic content, if it increase in soil, then water requirement will be also less because water permeability of soil will decrease and it will hold more water. This type of things happens. So even I have seen in IIT Kharagpur that vermicompost and these things have changed the topography of the area. It was a barren land with moram soil, and now with the use of organic farming, they have made it a very cultivable, very productive land. So these things are required in our context. And right now I am not presenting my PPT because I am using through a mobile technology. And once I will finish it, my PPT will be shared to Mr. Sati Prasad. And moreover, we should place for saving our water footprint, how to earn more and more water footprint by simple technologies like tipping tap, where tap senses how much is our requirement, etc. And so on. Having sensing technology in our pipeline system, we can find out from where it is leaking. And in our homes, we with our common knowledge that during taking bath or during washing our mouth, we should not open the tap for whole time. So these are the simple things we can save water and contribute to lot to the nation. And government of India is already trying, pushing hard to save water, to conserve water, to make water pollution free. It is the individual responsibility to everybody that we contribute wherever we are towards saving of water or towards non-polluting of water by throwing garbages here and there, particularly using of plastics. And it's a great problem now has come that microplastic which has gone into the sea or the water bodies they are disintegrated into finer and finer particles, and they take millions and billions of years to finally get into a different form. So we should not use plastics. Government has taken a good measure that one-time single-use plastics has been banned in Government of India. We should also be thankful to the Government of India and also contribute from our side that we should not shy off. We should shy off using the single-use plastics, and people should make aware the other person who are not so educated and literate about this. So with these, I think I have made my presentation, and if you have any questions, I am open. Hello, Sati Prasad ji,
Yes, sir.
you are listening to me?
Yeah. Hello, sir.
If
I am-
any questions, anybody want to know about the water irrigation, etc., programs launched by Government of India or achievements, etc., I am open to.
Okay. Sir, I have one question for you. Hello, sir.
Yeah,
Yeah, I have one question for you. So now we are
yeah.
facing the water crisis problem as well India as well as the over the world. Okay. So I think rainwater harvesting can be solved this kind of issue. What are the best method for rainwater harvesting in India?
Yes. The best method, you everybody knows that ponds, storing water into the ponds. Then comes this is the surface type of storage. Then comes the groundwater storage. How do you recharge structures like making bore wells and taking the rooftop rainwater harvesting into that bore well that will go directly into the ground. Then aquifers where they mix up into the rivers. There you can make a barrier sort of that underground dams etc are also prevalent. So there are so many methods, and even plantation is such a good thing that some trees like people and bird tree, banyan tree etc are such a good water recharging trees that their roots penetrates into the hardest of the rocks and they disintegrate and make a fracture in that, and that whole of the land where that is a totally barren land can be made purely fertile land with lot of water. If you start planting these type of trees just in 50 to 20 years, you will find that their roots have gone deep, and these are the methods, and other are your other water harvesting techniques, and so many steps are being taken by government also for catchment area treatment. Well, there are so many methods in Rajasthan. You go and you find that bawdis are there. Bawdis are deep wells where they can be made just in any castle etc you might have seen. They have a lot of water efficiency system, and they are giving water for drinking for whole of the year. So there are the old techniques also, new techniques also, but main thing is how to improve the water efficiency, less wastages, and storing water during the rainy period. This is the main technique of your water. You can say the recharge and water harvesting.
Okay. Okay, sir. Thank you, sir, for your valuable lecture.
Sir, I have a question.
Yes.
So, if we talk about the big cities, then we can find out that there are various programs of the government which are very particular related to the water treatment. But if we talk about small cities, then there are no such program from the government which can treat the biodegradable wastage such as human feces and other household wastages. So what are the steps which government are taking to deal with such situation?
Yes,
As
that's what I will tell you, that National Mission for Clean Ganga has been taken for the Ganga, particularly. Even tributaries like Yamuna, etc., has been uh, come under its purview, but mostly Ganga around cities around Banaras and big cities across Ganga, Patna, then even your Howrah, etc. They have come under the purview of NMCC. But due to financial constraints, it's very difficult to go into the small revolutes where the human feces, etc., are polluting the rivers. But I will tell you that these are not so hazardous pollution. Pollution is basically when the industrial pollution comes into the river, then they create a havoc for treating the biodegradable waste into the river, pour into the river. There is a self-cleaning process of the river also. If the river flows for a long distance with the aeration and movement, the water get cleaned, and even natural cycle also cleans it. But unfortunately, you are correct. No such system is existing for small areas, and government has not that much of resources to even to clean your Yamuna river in Delhi. Then what to talk of the small cities? So first, the government is concentrating on major cities like Delhi, Kolkata, etc., where the water can be purified and taken to the river. For small cities, we don't have that much of resources. We are not able to do it, frankly speaking. That will require a lot of resources, and we have prioritized our programs so that we can contain the pollution in big cities where a lot of population of are there, and in small places we are awareing the people to of about the fluoride, arsenic, impurities. Hardly we are now Jal Jeevan Mission, through Jal Jeevan Mission, government is trying to give pure water to every household. So the problem that is coming in the river after filtration, even in a small places through Jal Jeevan Mission, the water treatment plant will be established, and from there a pure water, at least a drinkable water, will be supplied to every household. So government is taking a lot of care about our health, and we are trying even in the smallest and smallest places, very far off remote places, a Jal Jeevan mission is being launched.
thank you, sir.
Thank you.
Thank you, sir, for your valuable lecture. And I hope our audience is having no further questions. So, with this, I'll continue. And I would like to welcome Dr. Neelanjan Patel, a professor from Department of Remote Sensing, Birla Institute of Technology, Ranchi, India, to speak and share his knowledge on the remote sensing and GIS-based studies in land and atmosphere, concept and applications. Over to you, sir. Sir, if you can please address our audience.
Yeah. Now I have to go to that. To Usmanira, it is not coming. The sharing mode. तो 3 dots में आना है, कहाँ पे आना है? तो how to share my presentation? Entire screen or window? Entire screen. Entire screen. Okay. Then okay. Yeah, just a minute. Yeah, now it is coming, I think. Right. So now I will open my PPT, right? So it is now visible. Okay, thank you, thank you. Yeah. Okay, good afternoon, everyone. And probably I might have been introduced by Dr. Sati Prasad. So I had planned to give a talk on this particular topic, remote sensing and GIS-based studies in land and atmosphere, concepts and applications. But somehow, I mean, maybe the presentation that I will make might have some deviations from the title of this presentation, because I could not incorporate all the materials that is required here. So I think all of you have the remote sensing and GIS background. I think so. So this is just an introduction that what is remote sensing. All of you are quite aware of this, hopefully. Is it Dr. Sati Prasad?
Sir, yes, sir.
Their background, I think, is all remote sensing students.
Yeah, background is various remote sensing, geography, environmental science.
Yeah. So this particular diagram as well as the definition has been taken from the book Lillison and Kiefer, and it was just an introductory slide to make you familiar. So what I am going to present today in this particular lecture presentation. One is how a particular satellite is used to determine or estimate the underground water. That is the GRACE satellite. And another is the runoff estimation from rainfall using SCSCN curve number method. So there are 16, 17 slides. I hope I'll be able to complete in time. So measuring gravity from space. This equation has already been defined long ago. And with this equation, or with the concept involved in this equation, the gravity recovery and climate experiment, that is the GRACE satellite, has been functioning or has been made operational. So GRACE is a joint mission between NASA and German Aerospace Center. And the concept is like this: gravity is present everywhere. We are familiar with gravity because we live with its effect every day. We know that when we drop an object, it falls to the floor, and we know that gravity is the reason. While the force of gravity is weak, compared with other forces in nature, such as electricity and magnetism, its effects are most far-reaching and dramatic. Gravity controls everything from the motion of the ocean tides to the expansion of the entire universe. So how does basically this particular satellite work or sensor work? Okay, so here we can think of gravity as the invisible force that pulls two masses together. When we speak of mass, we are talking about the amount of matter in a substance. And density is a measure of how much mass is concentrated in a given space. Sir Isaac Newton has discovered that as an object's mass increases, the gravitational attraction of that object also increases. The Earth's moon has considerably less mass than the Earth itself. Not only is the moon smaller than the Earth, but it is only about 60% as dense as Earth. Thus, the gravitational attraction on the moon is much less than it is here on the Earth, and a person weighs less on the moon. Yes. Oh, okay. The Earth's topography is highly variable with mountains, valleys, plains, and deep ocean trenches. As a consequence of this variable topography, the density of Earth's surface varies. These fluctuations in density cause slight variations in the gravity field, which remarkably the GRACE sensor can detect from space. This is the source from where the material has been taken. So gravity, the GRACE as such, is the Gravity Recovery and Climate Experiment, a NASA mission consisting of twin satellites that were launched in March 2002. Okay, how does GRACE measure the gravity? Okay, I'll explain it in the following diagram, but I just read it out here. As the lead satellite passes over an area on Earth of slightly stronger gravity, it detects an increased gravitational pull and speeds up ever so slightly, thus increasing its distance from the trailing satellite. Conversely, the lead satellite slows down when it passes over an area of slightly weaker gravity, decreasing the distance between the two satellites. The changes in distance between the satellites are so minute, about 1/10 the width of a human hair, that they are undetectable by the human eye. But GRACE measures these changes using an instrument that generates pulses of microwave energy, a highly energetic form of electromagnetic radiation that bounce back and forth between the two satellites. The distance between the satellites is determined by the time a microwave pulse takes to travel from one satellite to other and back. And this is the concept involved here. So this is not the actual photograph of the satellite. it cannot be. So this is the lead satellite and this is the trailing satellite. It appears they are connected by a rod or cylinder, but it is not like that. This is just a the visionary the animation photograph. So the GRACE mission detects changes in Earth's gravity field by monitoring the changes in distance between the two satellites. So the distance between these two satellites, they change depending upon the gravity or the density of the mass present below these two satellites. This drawing is not to the scale. The trailing spacecraft would actually be about 220 kilometers behind the lead spacecraft. So GRACE maps the entire gravity field of Earth every 30 days. That is, the temporal resolution is 30 days for the entire Earth. The changes in gravity over time can reveal important details about polar ice sheets, sea level, ocean currents, Earth's water cycle, and the interior structure of the Earth. The various applications are: GRACE has found that the ice sheet that covers most of the Greenland is shrinking. Measurements of decreasing gravity over the ice sheet, thus indicating a decrease in the ice sheet's mass, showed that a loss of about 150 billion tons of ice per year between 2003 and 2006 has been lost. Melting ice sheets and glaciers contribute to rising sea level worldwide. The melting Greenland ice sheet contributes about 0.3 millimeters per year to a rising global sea level. GRACE also continues its measurements to understand whether this rate of sea level is rising or decreasing. In Africa and Australia, decreases in gravity are evidence of drying river basins. GRACE not only measures the changes in water above ground, but also it senses the amount of water stored in aquifers beneath the Earth's surface. This kind of information can enable better management of scarce water resources. GRACE can also detect changes in Earth's crust brought on by earthquakes, such as the 2004 tremor in the Indian Ocean that triggered the deadliest tsunami on record. The quake changed the density of the rock beneath the surrounding sea floor, which GRACE was able to see several months later as a change in gravity. GRACE can also estimate differences in the mass or bottom pressure of the oceans. Taking a page from weather forecasting, which uses atmospheric pressure gradients to estimate wind velocities, GRACE measures ocean pressure gradients to estimate monthly changes in deep ocean currents, such as the very important circumantarctic current. So the next topic that I will discuss is the runoff estimation from SCS-CN method. So the USDA, United States Development Agency, SCS-CN method is widely used for the computation of surface runoff. The parameters used under these are land use, land cover categories, soil cover, and the antecedent moisture condition of the soil. If a basin comprises different LULC categories, then the composite CN number is computed to determine the runoff. And the runoff equation is this. Q is the discharge of the runoff in inch. That is the P minus IA square of the entire, the whole term. Then P minus IA plus S. S is the potential maximum retention after the runoff begins in inch. And IA is the initial abstraction. And initial abstraction IA is the amount of water before runoff, such as infiltration and rainfall interception by vegetation. The CN number or the curve number values are tabulated in the National Engineering Handbook for various land cover categories and differential soil textures. That I will show in the next slide. And Q becomes 0 when this P, that is the rainfall of the precipitation, is less than the initial abstraction. And Q is given by this equation when situation is P is greater than IA. This is for converting the inch to centimeter. So these are the different CN number for different classes, land use, land cover classes. These are the cover types: pasture land, grassland, meadows, brush, then woods, and these are the cover descriptions. I mean, like ground cover, heavily grazed, not heavily grazed, slightly grazed, less than 50% ground cover, 50 to 75% ground cover, this brush or the weeds, like that. And these are the different hydrologic soil groups A, B, C, D, that I will explain in the next slide. What is A, what is B, what is C, what is D. And for each one of them, hydrologic soil group, and for each of these classes, these curve numbers have been determined by USDA. So for instance, if the land is pasture land and ground coverage less than 50% grazing, then the curve number will be 68 for hydrologic soil group A. For this particular condition, for the same, for another hydrologic soil group, the curve number will be 79. So what are the different hydrologic soil groups? Group A basically is the sand, loamy sand, sandy loam types of soils. These soils indicate low runoff potential and high infiltration rate even when it is wetted. They consist of excessively drained sands or gravels and have a very high rate of water transmission. Group B is silt loam and loam, which has moderately infiltration rate when it is thoroughly wetted. Group C is the low infiltration rate when it is thoroughly wetted. So this is basically sandy clay loam and the soils that resist downward movement of soil and water with moderately fine to fine texture. Group D is clay loam or silty clay loam, sandy clay, silty clay, clay that is the highest runoff potential and very low infiltration rates. So based on the infiltration potential and runoff rate, 4 different types of hydrological soil groups have been determined. And depending upon in which land use land cover category each one of them falls or it is covered, different CN number has been given. Different CN number has been given. So I told you that if a particular area covers different classes, then a composite CN is determined. Composite CN is determined. So composite CN is this one. I is the land use land cover class. AI is the area of the each land use land cover class. These two are multiplied. Summation of this divided by the total area of the class. That is the composite CN. However, if we want to have adjust the slope percentage in each area, then CN3 is calculated, which is given by this equation, and that is CN2 and exponential of this particular value, and CN2 is calculated by this equation. What is SLP is the average slope percentage. So weighted CN becomes like this. Just like composite CN, then weighted CN is calculated like this. So using these equations, where the CN values are used to calculate S, and S and P are used to calculate Q, and IA is nothing but a 0.2 multiplied by S. One can determine the runoff in a particular area with the increasing rainfall. For instance, this study has been done in one study area, the Nepalganj watershed, and with AMC3 condition for open forest category, and we found that there is very high correlation between the rainfall and the runoff. So as the rainfall increases, the runoff also increases. Similar study has been carried out in the same station, but for the built-up land. This is for the open forest. This is for the built-up land. For the AMC3 condition, so this is the increasing rate of rainfall and accordingly increasing rate of runoff. So this is how rainfall runoff estimation is done using the SCS-CN method. Okay, I hope I have been able to give a good explanation. If you have any question, please ask me. These are the references. Should I stop now? Any question? Okay then, so I stop here. Dr. Sati Prasad, can I stop now?
Yes, sir. Yes.
Okay then.
Thank you, sir. It was a great session indeed, and it was really a brainstorming session, I would say. And thank you for your presence, sir. Now, for further continuing our program, I'd like to extend a warm welcome to Dr. Ratnagar Swain, the Assistant Professor from the Department of Civil Engineering, National Institute of Technology, Rourkela, India, speaking and imparting his expertise on the catchment treatment plan on the Terra Reservoir sedimentation. Over to you, sir. Sir, please turn on your microphone.
Mute.
Okay. Good afternoon, everyone. Thank you, Bhumika and Satyaprasad, for the invitation. It's my honor to present one of my work. So, actually, I am to present a topic related to recent publication, but not exactly the reservoir sedimentation, but it is about the pollution monitoring at a spatio-temporal scale, finer spatio-temporal scale, using remote sensing. Is it visible?
Yeah.
The
Yeah.
slide? Okay. So this is the topic. Hello?
Yeah. Continue, sir.
Okay, this is the topic which is recently published. That's why I changed to this topic, that is pollution monitoring at finer spatio-temporal scale using remote sensing technique. So here in this topic, we'll discuss about what is the problem in the real-time monitoring of water quality parameters, and how using we can monitor the water quality parameters, and what is the methodology and the algorithm that is I followed, and the case study where I applied the algorithm, and what is the result we got, that I saw. So here we know that is, all of you know that river cleaning is a major challenge in India, especially some rivers. If you consider the one river, that is the Brahmani river, it is in Odisha, it is highly polluted. Means there are 37 major industries are there, including the mines. There are 37 major industries, and the State Pollution Control Board is the responsible for measuring this pollution at different stations. State Pollution Control Board is under the CPCB, Central Pollution Control Board. They measure the pollution at monthly basis. From 2010, from year 2010, they are measuring at monthly basis. Before that, it was quarterly basis. So they follow the conventional procedure like sampling, and then in the laboratory they measure. Means you can say laboratory-based measurement. There's no doubt that laboratory-based measurement is most accurate. That we have to accept. But however, it is costly procedure. It's not suitable for river pollution monitoring at very spatio-temporal scale. Let you want to measure at a daily scale. At a daily scale, we cannot go to the river and we cannot take sample and cannot measure at the laboratory. So at a daily scale and also the area which is not accessible, especially during monsoon period, during drought season. Some areas we cannot access, we cannot go there, and we cannot take sample and cannot measure the pollution. So for that, this is the comparison of these testing methods. What is the laboratory testing method? Laboratory testing method that is that I told that we have to take the sample from the river and you have to measure you have to test in the laboratory. It is most accurate, but it's cumbersome procedure. It involves high cost and it needs more expertise, and it's dangerous during high flood, especially during monsoon period. So it's not suitable for finer spatiotemporal measurement. Similarly, in sensors are used. Different sensors are used. We can go to measure at real-time measurement is possible. Means we can go to the site, we can measure. But problem is that the sensors need calibration at regular interval. So, and another point is that all sensor cannot measure all parameters. The sensor can measure, a particular sensor can measure some particular parameters. Okay, so and during this monsoon period, it is difficult to go to the site and cannot measure. So if you say at finer spatiotemporal scale, that is also a problem. Okay, but only plus point is that it's in digital sensing method, we can measure at the river only. It's not required to bring the sample to the laboratory.
Excuse me, sir.
Yes.
I think your slide is not moving.
Slide is not moving.
Yeah. So please change your presentation mode and.
It's in presentation mode.
Okay. And now it's okay.
Okay, it's actually okay. And I think it's not working the full screen. Okay.
And,
is it visible now?
Yeah, it's visible. And
Okay.
I think it's in the full in mode.
Okay. So this is the this we discussed, and this is the two method, that is laboratory testing method and digital sensing method that I was talking about. Digital sensing means it uses different sensors and which is not suitable for carrying out this finer spatiotemporal measurement because it needs regular calibration and it requires high cost. And a particular sensor cannot measure many parameters. Only few parameters can measure. So these are the and the visual interpretation has no meaning. Okay. So now comes to the remote sensing based technique. This remote sensing based technique, you can measure the water quality parameters as finer spatiotemporal scale. So in this particular study, so also how we can measure at 30 meters spatial and 1 day temporal resolution. So you can measure we can monitor the pollutants at a very finer finer scale. Then pollution source identification can be carried out. Means where the source is located. Where is the source of pollution is located, that we can identify. Accordingly, the policy decision and management, pollution management can be done. It means the industry or the sources which are polluting are discharging the pollution, that can be regulated. And it does not require any cost. It is no cost involvement because in this study, in this particular study, we have used freely available satellite images like Landsat and MODIS. So here, this literature, these are the different literature existing that means all the works on these water quality parameters in different water bodies like lake, river, okay. And but nobody have concern on this finer spatiotemporal scale. Nobody has taken this factor on this resolution, okay. And very few parameters are considered by these different scientists, different authors. Okay, and this is the total the satellites, the different satellites which are working till now. Maurice, Landsat, Aster, Icons, Kuiper, and Visat, Spot5. The characteristics of these satellites are given here in this table. The country launched and the launched date, spatial resolution, temporal resolution, spectral range, number of spectral bands, everything is given. Okay, only one latest that central one satellite is missing. So more or less every satellite. Since we have considered here Landsat and Maurice, that's why I have mentioned here about the Landsat and Landsat 8 spectral bands, different bands, blue bands, green band, red band, different wavelength, and the resolution is mentioned here. So you can see the Landsat, we know that is 30 meters spatial, but it is 16-day temporal resolution. So you can say high spatial but low temporal. In the Maurice, you can say these are the different bands, and the characteristics of this Maurice satellites is given here. And this Maurice band spatial resolution is 250 meter to 1 kilometer. It varies from band to band. First two band, if you take M1 and M2, then it will be 250 meter. And if you take upper bands, then it will be 500 spatial resolution. So like it will, in thermal bands, if you take it is 1 kilometer. So it will vary from 250 meter to 1 kilometer. But the plus point is that here temporal resolution is 1 day. So you can say high temporal but low spatial. So here, how this Landsat and Maurice satellite images is used to measure these water quality parameters. And this is also called indirect based method. Indirect based method means here we have considered particularly the heavy metals, because the industry which are present in the Brahmani site in the Platini region, mostly the heavy metal industries are there, iron industries, minings. Okay, so it's highly polluted river. That's why the industry, the heavy metals is considered here. And we know the pollutants affect the properties of water, all this pH, temperature, TSS, turbidity. Okay, so all the heavy metals or any kind of pollution, it will affect the TSS, it will affect the turbidity, it will affect the pH, it will affect the temperature also. So this TSS can be used an indicator for indirect assessment of these heavy metals. Okay, TSS as heavy metals, we can the function of TSS. Okay, according to literature survey, it is found that heavy metal is function of TSS, turbidity is function of this TSS. This turbidity is most efficient estimator of TSS. Means from TSS only you can get the turbidity as per the literature. The spectral reflectance values, it is influenced by the turbidity. Okay, so this the reflectance value means the surface reflectance value. It is actually influenced by the turbidity values. So here the concept is that the heavy metal is function of TSS, TSS is function of turbidity, turbidity is function of this, especially the Landsat 3 and Landsat 4 band. Third and fourth band of the Landsat is usually affected as per the literature. It is found the mostly influenced by the turbidity. So here the Landsat 3 and Landsat 4 band can be estimated from this Maurice by using a star of M blending algorithm, fusion algorithm. It is a spatio-temporal fusion algorithm which is used to get the Landsat-like surface reflectance from Maurice surface reflectance values. And this in this star of M algorithm means in the fusion, the concept is that we can fuse the two Landsat satellite bands if both are spectrally similar. Means the wavelength range must be same. For the like here Landsat 3 and Landsat 4, the wavelength range is similar to wavelength range of first band and second band of Moody's. So here, the methodology, this is the methodology, the development of this first heavy metal TSS and TSS turbidity relationship using object data, the development of regression models using turbidity concentration and Landsat surface reflectance, and spatio-temporal data fusion of Landsat and Moody's satellite bands using star-frame algorithm, then water quality mapping. So this is about the star-frame model. We know that Moody's image, that is 250 meter and 1 day resolution. That means high temporal and low spatial. And Landsat, it is low temporal and high spatial. It is 30 meter and 16 time. So using this algorithm, a synthetic Landsat light surface reflectance can be estimated, which will give the 30 meter and 1 day resolution. So it will be high temporal and high spatial. So this star-frame algorithm, this is the concept. This algorithm can be applied in two ways depending upon the situation. If the land cover is changing over the time and over the space, okay, then it's changing, then that is called in equilibrium condition. And if the land cover is not changing with respect to time and with respect to space, then that is called equilibrium condition. And here we have considered the flow portion of the river, only the flow portion of the river, center of the river. Okay, we have considered only center of the river, not the side of the river. Because the center of the river, anytime you will find the water throughout the year, because it is a perennial river. Any point of time in the year, throughout the year, there will be water. So land cover will not change. That means it is a case of equilibrium condition. So in equilibrium condition, we can use this linear approach. Linear approach means that at a different time period, at different time, the difference between Moody's and the Landsat surface reflectance will remain constant. Like here, the Landsat, we have at a time period, like at a time T1, we have data, and after 16 days, at another time period, that's T2, we have the data. Then this is known. But if you want Landsat surface reflectance in between these 16 days, in between 16 days, let here if you need, then here we have to, it is unknown because here we don't have Landsat surface reflectance value. But the Moody's data, if you say at a T1 or T2 or any time period T, there is data, because it will give you every day it will give the data. That's why if you take the difference at different time period, it will be set. Means the linear relationship can apply to measure the Landsat light surface reflectance at time T. This is the overall methodology. Means first Moody's and Landsat satellite images we have to collect, and the processing, user processing, reprojection, resampling is carried out. Sufficient number of surface reflectance data coincident pixels of Moody's and Landsat images at time T1, T2 at center of the river is carried out. Then estimate the Landsat surface reflectance for the image at time T2 using the star-frame algorithm. In this portion is about the star-frame algorithm. Then after verification of this algorithm, then it will be applied here in this water quality mapping. Means location of in situ data collection sections. Okay, collection of in situ water quality data is collected. Then the linear and nonlinear regression analysis and genetic algorithm combinedly, it is used to get the relationship or the formulation between TSS turbidity and TSS heavy metals using 60% field data calibration purpose, and selection of best correlated TSS TO TSS heavy metal concentration model, then validation using the 40% data, and generation of concurrent database of Landsat surface reflectance turbidity at in situ gauging stations. Okay, so these are the genetic based algorithm based nonlinear and spaces based linear regression analysis used to get the TSS turbidity and the Landsat surface reflectance. The relationship will get. Then after that, after getting the relationship, we get the estimate turbidity, TSS, heavy metals concentration at daily, temporal, and 1 kilometer spatial scales of the river. Then water quality mapping is carried out. Then uncertain sensitivity analysis also can be done. So here, this is the same procedure. Only briefly, I have mentioned here because it's very this procedure is very long. So that's why there's a briefly procedure I've mentioned here. So this is about the heavy metal pollution index. How to estimate this heavy metal pollution index? This is the formula, standard formula for the HPI, where this W, Q are the sub-index and unit weightage. Q is the sub-index, W is the unit weightage of the ith water quality parameter. N is the number of heavy metal parameters. This Q is estimated from using this formula, where these variables are nothing but these are the actual, highest, desirable, and standard permission values of ith heavy metal parameter, respectively. Considering this IS 10500, that is Indian standard of permissible and desirable heavy metal concentration of drinking water. Means these are the list of parameters which are considered here in this study. This is the standard permissible values, highest desirable values, unit weightage, means here x, these are the variable x is I suffix, x suffix I, w suffix I, y 1 by x suffix si. So these variables will get, and from these variables will get the qi. And this qi and the unit weightage will be given for each parameter, and the HPI is measured. And the HPI value for drinking water purpose, the critical value is 100. Means more than 100 if the water is polluted, means it is critical. Then this is the Brahmani river that I was talking. It is heavily polluted. This report, you see here, it is 15 stations. 15 industries. 15 industries in 2005, as per this PSP report. In 2005, there was 15 industries. Now, in 2022, if you see, these are the industries. The red points are the industries. There are 37 major industries now. So it is hugely totally industrialized area in this basin, this Brahmani basin. Means these are the 37 means major industries. There might be many more minor industries. And this is the your PSP monitoring stations. There are monitoring stations. Okay, the location of monitoring stations, and these red maps are the location of industries. This is just an article, local newspaper about the pollution, how the river is totally polluted. This is about the this article, newspaper article. And this is the SPCB monitoring stations in the study area. These are the name of the different stations. There are 25 monitoring stations. Total, if you consider from this last station to this first station, sunk upstream to this all 25 the number, okay, from this conference point, okay, to the last point, it will be around 400 kilometers. Up to Janapur here, up to this station, it is 300, it will be around 320, it is said to be 400 kilometer, 400 length of the river. Length of the river is 400 kilometer. So out of 400 kilometer, you see in the 400 kilometer length, there is only 2. Okay, in this for this study, these are the sources. Odisha State Pollution Control Board, the data is collected, and Odisha and Landsat data is collected from these sites. This is this Brahmani river. The sample images are taken from Moody's image using Moody's and Landsat. These are not to scale actually. It's not similar scale. So this is the validation of this star FM algorithm. First, initially the star FM algorithm is validated. As I told that L3 and L4 bands are estimated using the M1, M1 bands using the star FM algorithms, And you can see how the estimated and the observed values are matching. Okay, you can see this is the about this performance evaluation measures: NASA trip efficiency NSE, R square, root mean square error, and index of agreement. So these are the evaluation measures. It shows that around from 75, it varies from 75% to around 80 or 85%. R square value varies from this 75 or 70% to 80%. Okay, and RMS value is very less. These are the formulations that genetic algorithm and the regression analysis combinedly used to get the relationship between the different heavy metals and the TSS. And this is about TSS and turbidity. In different ranges, the equation is different. If it is less you, then this is the first equation you can use. And if it is from 50 to 200, this equation, and if it is more than 200, then this third equation. And using this genetic algorithm and this regression analysis, combinedly, we have formulated this relationship between this L3, L4 and turbidity. Various combinations of L3, L4, possible combinations of L3, L4 is taken here. All possible combinations of L3, L4 with turbidity is taken. So it is log turbidity into, is equal to this equation is the final formulation between the turbidity and L3, L4. So this is the performance of these formulations during calibration and validation. During calibration, you can see here it is varies from 73% to 92%, 76%, 0.76 to 0.91 R value, R square value. Index of agreement, RMS value, is, you can see it is giving satisfactory result. You can see here that this is the a scatter plot between this estimated and observed data of during calibration and validation of different parameters, including turbidity and TSS. So you can see this scatter plots. You can see here this actually lower values are not a little deviating from this observed values, but the when the value is high, the higher values are mostly matching with the object values. That means if river is highly polluted, then this approach will work. And after getting performance evaluation at different points in the along the river, this and different time period, it is estimated. Different time, this water quality parameters, heavy metal are estimated. Here you can see from 2015 January to 2015 June, it is showing whatever using the formulation that is estimated value and object values. This is the from this and it is estimated at culture at one point. At one point, culture I have taken 1 point because at every point it is difficult to show here. So at 1 point I'm showing at culture only, and it is from January 2015 to June 2015. These are other parameters. This is the spatial distribution. Spatial distribution means from this compressed point to the Jenapur. And from you can see here 0 to 320 kilometer. Up to Jenapur it is 320 kilometer, and this is the estimation of different heavy metal parameter. And it is actually average value of January period is taken. January 2015. Daily average is taken of month January 15. From compressed point to this Janapur at every 1 kilometer. These are the other parameters. And this is the water quality vulnerability mapping according to this IS standard. It is found that the river is highly polluted with turbidity, iron, and most of the places are polluted with the TSS. And these values as per the Indian standard, whether it is safe or it is warning at warning stage or it is in critical stage. And this is about the other parameters. Like here, the lead, it is also polluted with lead and cadmium. this the HPI, heavy metal pollution index, that I was talking. That heavy metal pollution index is calculated based on this StarChem approach. This culture gauging station, this is the temporal distribution, this is the spatial distribution. At that culture gauging station from January 2015 and June 2015, it is calculated. And you can see the most of the places, most of the time, the SPI is more than 100. And the spatial distribution, if you see, at every 1 kilometer, it is estimated from that conference point to Janapur, and it is SPI, most of the places, it is SPI is more than 100. Okay, so this SPI value shows how the river is polluted at different time and different points in the river. And this is also taken average values of the month January, daily average, the 15. This is a spatial distribution, this is temporal distribution. And this is the SPI mapping of the river, of the stress, is altitude to Janapur. Whole stress, I'm not showing, only the altitude to Janapur I'm showing. Here are in high SPI value, which is 3200, and few places it is more than 100 critical SPI value. Okay, and very, very few places are at less than 15, that is low SPI values. That means using this, this is the conclusion that we got. The StarChem algorithm, Modi surface thickness values up to 250 resolution can be effectively downscaled to synthetic Landsat like surface reflectance values of 30 meter resolution. Brahmani river is contaminated with turbidity, TSS, lead, cadmium during the study period. High to critical values of SPI in major part of the Brahmani river during the study period indicates high heavy metal pollution. The developed StarChem algorithm, Modi used for real-time monitoring of conjunctive pollutants of this parameter resolution during cloud-free days. Only restriction is that, the limitation of the study is that it is during cloud-free days only we can measure the pollutants. Okay, this is where the publication of this particular work that is published in Journal of Environment Management. Here are the references. Thank you. I think I've taken more time. If you have any question, you can ask.
Sir? I request our audience to come with the questions if they have any. I don't think that our audience have no questions, and we'll proceed further. Thank you so much, sir. It was really a good session. It was really, it has really enhanced our knowledge on the topic. And now I would like to invite Dr. Satabdi Vishwas, Associate Professor, Marinalini Datta, Mahavidyapeeth from the University of West Bengal. I'd like to wish a hearty greeting and speaking and sharing her knowledge on social economic analysis of RWH, a case study of 24 currents. Over to you, ma'am.
Thank you. Good afternoon. Am I audible? Dr.
Yes,
Shruti
ma'am, you're
Prasad?
on.
Yeah.
Okay. So I am honored to present a paper in front of such august audience. So, It is working?
Yeah, yeah.
Okay. So the topic of my paper is socio-economic analysis of rainwater harvesting, a case study of 4 blocks under North Province, West Bengal. As we know that water is not evenly distributed throughout the world. Globally, 2.5% is fresh water, out of which only less than 10% required for domestic purposes. Population increase with all developmental works create tremendous pressure on water. Thus, water crisis has 2 dimensions mainly, that is qualitative and quantitative water stress. In India, easy access to a shallow aquifer is responsible for unethical drafting of groundwater. And since 1970, mainly for Boro cultivation, that is the winter paddy, it needs more intensive water from shallow tube well. So gradually the tank and canal irrigation area were declined, as we've seen here in this slide, that from 55% to 31%, whereas the tube well irrigated area was increased from 38% to 64% from 1971 to 2004. And per capita water availability will decreases from 1,401 cubic meter to 1,119 cubic meter between 2025 and 2050. Thus, India become a water stress country, and more than 80% Indian rural people solely depend on groundwater. While drafting the groundwater, many contaminants like arsenic, iron, fluoride come out from the subsurface to surface. And arsenic is extremely toxic and carcinogenic metalloid, as we know. And surprisingly, people believe that groundwater is a safer source of drinking water. But high concentration of inorganic contaminants like arsenic are causing health hazards. And also iron is also causing health hazard. So more than 90% of the arsenic contamination is geogenic by nature. And while in 2012, as per IS 10500, the permissible limit of arsenic was 10 ppb. The first case of arsenicosis patient was recorded in 1983 in West Bengal. And at present, 2.19 million sufferers inhabit in 111 blocks of West Bengal. Arsenic threats are aggravated by poor socioeconomic status, illiteracy, regular consumption of contaminated groundwater. Apart from different type of arsenicosis, households are also suffering from diarrhea, gastrointestinal problems, skin cancer, etc. And arsenicosis patients face serious social impacts such as marriage-related problem, unemployment, rejection by the community, and all these are ended with the social loss. So under these circumstances, rainwater harvesting is very important alternative source of water. And rainwater harvesting is a simple technology of direct collection and storage of rainwater necessary for productive human use. Here I can share the water governance that we already have. We have lots of water conservation projects from central government and state government. Those are Bharat Nirman, Hariyali, National Rural Drinking Water Program, Sajol Dhara, Jal Dharo, Jal Bharo, etc. And understanding the severity of the problem, the state government formed an arsenic task force in 2005 and 2006 for the entire arsenic infected area of West Bengal. And they recommended groundwater based PWSS, means public water supply scheme, attached with arsenic removal plants, and gradually introduction of surface water based PWSS supply scheme. Unfortunately, even after 75 years of independence, Indian water bureaucracy still tries to find out a water vision plan. So incidentally, rainwater harvesting has been made mandatory for the urban areas by the municipal rule 2007. But rainwater harvesting is still not appreciated by the government and local people. Thus, water become a figurative resource. So the research gap is, I found that it is assessment of the feasibility of rainwater harvesting in the areas suffering from both qualitative and quantitative water stress, and the socio-economic assessment of feasibility of rooftop rainwater harvesting, that is RRH, for rural households. So the objective of this paper is to explore the physical and socio-economic feasibility of rainwater harvesting for serving defined domestic purposes of the rural household in the arsenic iron contaminated areas. And I divided the entire work into two phases. The first phase is assessment of the qualitative and quantitative water stress for the study area. For groundwater and surface water data, I collected data from SWEET, PHED, and CGWB, and I used satellite imageries for developing land use land cover map and normalized difference built-up index. And I also develop water deficit zoning map by terraclimatic data. And for the thematic map, I use QGIS 2.8 software. And this table is show the detail of the satellite data. So the identification of the study blocks was based on the 4 categories of the stages of groundwater development made by Central Groundwater Board in the year of 2013. And here we can see that I just selected 1 blocks from these 4 category, and the blocks are Barashat 2, Boshihat 1, Amdanga, and Barakput 2. So this is my study area, and this is the study blocks. This is Amdanga, Barakput 2, Barashat 2, and Boshihat 1, and these green dots are the household location. We can see from this table that more than 90% of groundwater drafted by all type of tube wells, like shallow tube well, deep duty, middle duty deep tube well for tapping groundwater from porous zone sediment and used for all purposes like irrigation, domestic agriculture, etc. industry. Shallow tube wells with big diameter having discharge more than 30 cubic meter per hour. The output of deep tube oil is roughly 15 times more than the shallow tube oil. Thus, deep tube oil is much more vulnerable than shallow tube oil, and it runs around the clock during the irrigation season. And overall, the maximum share of the land used for the cultivation of boro paddy, and except deep tube oil, all other tube oils are supposed to run 6 to 10 hours per day, but in actual they run more than that, and simultaneously illegal rent and drafting also happen. And we can see that Barakpur 2 already drafted more than 97%, so it is categorized as semi-critical zone. And Barashat 2, it is also drafted more than 71%, so Barashat 2 gradually entered into the semi-critical category. If we look at the 15 years well-wise data of SWEET, we can see that some tube wells got choked over the time span of 2004 to 2008 for Amdanga, and surprisingly were revived again in 2009. So it is a clear indication of the overdrafting, and also some tube wells had negative recharge, we can see here in Amdanga, and same trend we can see in Barashat and other blocks. So it is also indicating the withdrawal rate was much more than its natural recharge rate. So as a whole, all the wells shows a sharp decline of water level during the post-monsoon season. If we look at the post-monsoon piezometric well depth map, here it is Amdanga. We see that the southern section of this block, it had more than 6 to 20 mbgl decline rate of groundwater. In case of Barashat 2, it is a north to northwestern portion, has a decline of 5 to 10 mbgl, and the same we can see in south and southeastern portion of Barakpur 2, and for Boshihat 1, it is north to northwestern region, which is also a declining trend. In this table, we can see that all the blocks are contaminated by arsenic and iron, and in Barashat 2, it is 125. The Barashat 2 had the highest concentration of arsenic, and in case of Barakpur 2 and Boshihat 1, both first and second shallow aquifers are affected by arsenic contamination. And we see that in the first column, we can see that all the three aquifers are used for the drinking and drinking purposes. Nearly 66% of contaminated tubers were found in Barakpur 2. However, more than 96% habitation is found to be affected by high arsenic contamination in Amdanga block, and 4 villages each from Barakpur 2 and Boshirat 1 block, and 16 villages from Barashat 2 block were in serious threat of arsenic, as it has no surface water based PWSS according to PHED. Under these circumstances, some of the tubers were banned by the PHED, but having no other alternatives, households continue to consume such contaminated water. And many tubers and deep tubers of drinking water were not found in working condition over the year due to the significant decline of water level or lack of proper maintenance. If we look at the LULC change map of 2010-2020, we can see that in Amdanga, the built-up area was increased more than 10%, for Barashat 2, it is 22%. For Barakpur 2, it is 4%, and for Bashirat 1, it is 2% within the 10-year span. So as a whole, the increase of built-up area happened at the cost of agricultural land, vegetation, and water bodies. This implies a serious threat of surface water and groundwater depletion. If we look at the normalized difference built-up index map, we can see that the northern portion of Amdanga block, northeastern stretch of the Barakpur 2, western part of Barashat 2, and the entire southern section of the Boshirat 1 block are marked as hotspot area in terms of increased ratio of built-up area. If we look at the water deficit zoning map, here we can see that the north to northeastern portion of Amdanga block, a small patch of eastern part of Barakpur 2, southeastern part of Barashat 2, and again southeastern part of Boshirat 1 is more vulnerable to surface water deficit. Thus, we can see that the water stress is an important issue in the study blocks. Coming to the second phase, that is the identification of socio-economic and behavioral factor influencing rooftop rainwater harvesting. As we know that water use is a complex social exercise, thus water has some underlying pseudo impact. So unsafe drinking water is a key variable. So I developed 5 indices based on household perception-based questionnaire, and I surveyed and collected 923 household data, and variable were analyzed by SPSS software. The indices are obtained by adding the binary value of questions related to the specific indices. These 5 indices are namely HHI, that is Health Hazard Index, Water Insufficiency Index, that is WII, Water Awareness Action Index, that is WAI, Willing to Adopt Rooftop Rainwater Harvesting, that is WRRHI, and Poverty Level Index, that is PLI. And this is the perception-based question of the indices. And I found many arsenicosis patients during my field survey. So the health hazard have been a proxy of low quality of water. That's why HHI, that is the health hazard index, was the primary concern, and I have done bivariate contingency table chi-square test and multi-chronicity test. After that, the logistic regression was carried out to the HHI on the 4 indices, and HHI was dependent variable here. And we see that except PLI, all the indices like WII, WAI, WRRHI have a statistically significant effect on HHI. There was no such difference between rich and poor in terms of the water intake. Thus, the poverty level index, that is PLI, is not significant here. The model predicts 69.9% of correct result, and it can be concluded that household health had been largely affected by the unsafe quality of available water. My recommendations are: introduce appropriate land use for the exact purpose, restrict and penalize illegal construction and land filling, And region-wise micro-level aquifer maps, arsenic iron-based vulnerability maps, and LULC maps should publish in public domain for awareness. Main focus should be shifted from the construction of high-cost arsenic treatment plant to rainwater harvesting, because it is very simple and anybody can do it. Introduce incentives for the success of rooftop rainwater harvesting, and existing schemes like Jal Dharo Jal Bharo, Pradhan Mantri Awas Yojana, Nijo Griho Nijo Awas, Norega schemes for rooftop rainwater harvesting are to be modified into a single scheme, and introduce simple technological know-how of rooftop rainwater harvesting by organizing frequent meetings, training, workshop, and social awareness program among rural households. So this is the selected references, and thank you.
Thank you, ma'am, for such a wonderful paper and as well as this lecture. It was really knowledge enhancing, and now I would like the attendees, if they have any queries, then they can come up with that. So I think there are no further queries from our audience.
Okay, thank you.
So thank you so much, ma'am. And heading on with our series, we will I extend my warm welcome to Dr. Mayan Suman, the Assistant Professor from Department of Civil and Infrastructure Engineering, IIT Jodhpur, India, speaking and imparting his expertise on the geographically distinct changes in extreme hydrological events over India due to changing climate. Over to you, sir.
Thank you for having me, and welcome to my talk on geographical distinct changes in extreme hydrological event over India due to changing climate. Now, every year, WEF, World Economic Forum, release a report that's called Global Risk Report in January. This is a graphics taken from 2020 edition of that report, and we can see all the top 5 risks were related to climate change. Now, these reports were published in January, so one might think that maybe the COVID scenario was not that bad at that time. So maybe the risk perception should have changed in 2022. This is similar graphics from report of 2022, and we still find top 3 risks to be related to climate change. And surprisingly, COVID is kept at 6th position in terms of infectious diseases. So one of the related extremes, one of the related risk is either climate change, climate action failure, or extreme weather. So our topic for today's talk, these hydrological extremes are related to both. Now, hydrological extremes are either excess or scarcity of water in any phase of water cycle. These extremes are becoming more frequent and intense with the changing climate. However, there do remain some local variation, and understanding of those local variation will help us in mitigating these extremes. Now, when it comes to modeling those kind of hydrological extreme under changing climate, we have multiple sources of uncertainty. In this talk, I will focus on these 4 sources of uncertainty using 2 different ideas. First one is hydrometeorological association, that is the association between hydrological and meteorological system that exist at different scales, maybe global or local scale, and also the idea that hydrological extremes might be interrelated. So one hydrological extreme may create favorable condition or evolve into another hydrological extreme. So the interrelationship between different kinds of extremes. So with this brief introduction, we started with the analysis of observed precipitation, the changes in observed precipitation characteristic between 1930 to 1970, and compared it with the recent values from 1971 to 2017. We found out that most of the regions showing increase in either mean and extreme precipitation are situated in southern part of India. Now here I'm using two different parameters for extreme precipitation. First one is M95 and second one is M99. M95 is the mean precipitation for the days when daily precipitation was higher than 95th percentile value for 95th percentile daily precipitation for that year. So these are in a way we can say it is mean mean rainfall for the days when there was a extreme rainfall. So these two. Now the natural question arises after seeing these pictures of these are the analysis on observed data. So natural question arises: are these changes expected in future or not? So we studied the future data also using cortex simulations. We found out similar trend. Even these trends are getting intensified. Either in case of mean, this first row is for mean, and then in case of extreme. In case of extreme, it is very interesting that almost for the entire study domain, whatever we have studied, South Asia, most of the region registered increase in extreme precipitation. However, the southern India and the regions and these countries of Thailand, Myanmar, register higher increase in extreme precipitation compared to other parts, especially northern India. So why these changes are happening? Why these changes are happening in a very geographically contrasting way? To understand these changes, we started with modeling of hydrometeorological association for precipitation. In brief, what we are doing is we are trying to decompose the precipitation and the factors that might affect precipitation into their wavelet component. And these components will have two parts, memory and exogenous part. So memory can be modeled using any autoregressive model. Here we are using kernel estimator. And whatever residual is left, we assume it to be the effect of other forcings, other meteorological forcings. So we model it using ARX model. So this is the same, whatever I have said, the same thing in pictorial form. We have some kind of target variable, that's precipitation, and some kind of independent variable like air temperature, total precipitable water, and so on. We decompose them into their components, and then we predict their memory using kernel estimator, and whatever residual is left, we predict the residuals using the decomposed coefficients from independent time series, or we can say meteorological forces. So this is the way it is done. Now, at the end, we have to reconstruct because we decomposed. We have decomposed the series first, so we have to reconstruct it back, and then we can study the performance of the model. Additionally, under this modeling framework, we can also go for something called relative importance analysis. It is a procedure in which we rank inputs on the basis of their importance in prediction. So we have used two of them, dominance analysis and Bombo importance measure. First one, dominance analysis. It measures the average association contributed by each of the individual input, and whichever input contributed more is naturally more important. Similarly, Bombo importance measure, it measures the criticality of an input in functioning of model. So the input that is more critical for functioning of model is more important. So based on these two, we can find out most important meteorological forcing that affect precipitation the most. So we started with 18 possibilities, 18 meteorological forcings that may affect precipitation, and we applied this model on 226 different sub-basins across India.
Unfortunately, Dr. Mayank Suman is facing some technical glitches on his end and he will not be able to continue the lecture. So that even I would like to say, even the best things come to an end, and our meeting and this series has come to an end today, and they are no exception for this. Therefore, I'd like to ask Ms. Bulu Bashak, that is a faculty of IIGST as well as joint convener of this event, to wrap up this gathering and provide us with a thank you speech. Over to you, ma'am.
Thank you, Bhumika. Thank you so much. And thank you, everyone, for your participation and valuable time. We are delighted to have today in this wonderful session. I would like to express my sincere gratitude to our guest of honor, Mr. Rajesh Kumar and Dr. Nicola Kranjesis for joining in this webinar despite their busy schedule. And I would like to express my sincere gratitude to our distinguished speaker, Dr. Ratnakar Swain, Dr. Shatabdi Vishwas, Dr. Moinak Suman, and to our guest of honor, Dr. Nilanchal Patil, for joining in this session. And last but not least, I would like to thank to the convener, Dr. Shahu, and our coordinator, Bhumika Kuel, for their arrangement. And finally, I would like to thank our chairman, Dr. Bishwajit Roy Chaudhary, for arranging such a platform for gathering and sharing knowledge about geospatial technology and water resource management. Thank you, everyone. Thank you so much.
Thank you, ma'am. And I'd like to ask the participants to enter their name in the sheet, which is in the chat box, so that we can provide them with the certificates and have their attendance also. Thank you, everyone.